Thanks, Paul. Good morning, everyone. Good afternoon and good evening, depending upon where you're logging in from. Happy Thursday. My name is Joe Alfano, Director of Marketing here at Neotys, and I want to welcome you all to the Automating Go, No-Go Performance Decisions in Continuous Pipelines webinar, Implementing Fast Feedback Loops with Load Testing and Continuous Integration. That's a mouthful, but we're going to dive in here in a second. Wanted to thank everybody for joining us. Quick recap of the housekeeping items, because I know that it's going to be critical for you all, especially as you get into the content here. The session is being recorded. We will take a Q&A at the end of the session. However, feel free to provide via chat at the bottom of the panel any questions that you have, and we'll facilitate towards the end during a Q&A session. And then, as typical with Neotys, we will follow up with links to the presentation, and very shortly, soon hereafter, we will have the webinar itself on our resources section so that you can direct any colleagues or other business partners to the content. So why don't we dive right in here? So what are we going to cover? What is the focus of today's Automation Go, No-Go Performance webinar? We're going to dive into what's needed. We're going to talk about some stories from enterprise scale performance teams. We're going to dive into considerations for automating Go, No-Go decisions and the decision-making process. Paul's going to walk us through some NeoLoad and CI pipeline examples, and then we're going to wrap with a Q&A session. And I'll also want to mention here that we've got you know, an hour planned, but we're hoping to get you out of here within 45 to 60 minutes, just so that you can plan accordingly. So today's presenters, I'm actually your host. As mentioned, my name is Joe Alfano. I've been at Neotys for just under 3 years. I have probably met some of you at some of our recent ramp-up events or on the trade show floor. So I look forward to seeing more of you and your companies in the future. But my information is here. If you have any questions, certainly follow up with my email. And I always welcome and appreciate LinkedIn connections. So there's my info as well. We've also got Paul Bruce, who's been at Neotys for just over 2 years. And he's a senior performance engineer, and he's done a lot of these webinars live and digital. He's got his info and vitals there, so feel free to reach out to him separately. He's always excited to take in some questions and foster some dialogue around DevOps and automation. Great. So I just wanted to set the table for Paul here. Couple quick slides just to sort of preempt the dive in on the automation topic. So, you know, one of the things from a marketing standpoint, you know, we always get exposed to new vernacular, and one of the things that I learned, obviously working very closely with Paul, is this idea of toil. And as Google SREs would tell you, toil is sort of operational, have to do work. It's firefighting. It's this idea of managing day to day, but not necessarily engineering type projects, sort of strategic focus. So when you talk about why automated and why continuous performance testing, this notion of toil, we say no toil, which I think quite honestly is a little bit more aspirational, because if you ask any performance engineer, SRE, they'll probably tell you that they'd much rather have less toil than what they have today. But I think trying to get to a zero toil is not possible, but we try to get to more of a 50-50, I think the industry would tell you. Project engineering work, do more of the operational stuff. So on the toil side, automation helps reduce manual errors. It enables you to take some of your repetitive actions and create reproducible, scalable processes. And automation ultimately enables the idea of self-service testing, which as we talk about information radiation, you can see that self-service function, if you will, something that can be done in more of an autonomous, flexible when the dev is ready to do type of approach. This information radiator idea, which is another trend that Paul turned me on to, I think it was a coined term back in the early 2000s, which kind of replaced the big value chart. But effectively, what this information sharing cultural shift allows is to provide trends as context. So understanding and having visibility into day-to-day performance gives you an opportunity to provide yourself and rest of team the opportunity to understand some of that context and be able to make decisions and respond rather quickly. It also enables you to be flexible, as I mentioned, and autonomous. So when you talk about things like clock speeds, effectively what you're talking about is being quick to respond and being able to have full communication and collaboration on a regular basis that you can act on. And lastly, it's about a pull forward approach. So, when you are automated and when you are practicing Agile, they sort of go hand in hand. It's a cultural, it's a mindset shift. We just did a survey. There's a ton of users that are either adopting, have adopted, or in the process of moving towards Agile, which is great. And that's obviously why we're here. And lastly, what you really want to talk about is being early and often, both in terms of requirements and SLO setup, as well as just having a ongoing performance continuous mindset. So that I'm going to hand you over to Paul. This is just a quick Google SRE quote. I think it's appropriate. If for nothing else, it enables you just to sort of understand this idea of going from manual to automated, repetitive to iterative. It takes you tactical to strategic, and what was devoid of enduring value is now providing enduring value going forward. And that's sort of the goal of the SRE approach. And this was a book. I don't know if folks on the line have been familiar with this, but it came out about 2016. So that I will hand it over to Paul, and I think we're going to kick it off with a quick poll to see where people are at.
Thanks, Joe.
Take it over, Paul.
Thanks, Joe. So I do want to just launch a quick poll because I like to get to know what people are doing and how they are able to synthesize some of the things that I've learned from customers and that I have the opportunity to share out now. So I'm going to launch that poll, and you should see that on your screen. I'll give it about maybe 30 seconds. This is a multiple choice question. This doesn't mean that you have to pick just one. These are statements, and you can decide which ones apply to you. So the first statement is obviously we have a really good performance requirements intake process in place now, right? At scale, you need to be able to bring that information in. I'm starting to see some people vote. Second one is performance incidents are traceable back to the stories and changes that were made. Ooh, not always the case, but maybe for you, hopefully. Third one is we have all the information we need to understand performance issues. The fourth is our organization is moving away from always on infrastructure. And the last one is we performance test web services to catch. And I think we got cut off because that's as far as testing web services sometimes goes. But the fifth question is we performance test web services. So I'll give it about 10 or 15 more seconds here while I review the chat just to make sure everything is working. Okay. Well, good. So we're still getting a few people to vote. I don't want to cut you off, but I think just getting a sense of what's the more likely situation that's going on here. So I'll end the poll now, and I will share the results so that we all get to see what we all said. So what you should see is a poll that basically shows us that about 30% of people say that they have good performance requirement intake process. Okay, I'm glad for those 30. I can't wait to talk with some of you folks about what you have in place or what you don't have in place and where you want to go with that. Then also 35%, about a third of people said that performance incidents are traceable back to user stories that changes that were made. Now that's a big deal. That's a really big deal, right? Cutting down mean time to resolution and actually being able to figure out how not to do that again in production. That would be a very interesting thing to get maybe a customer roundtable on and share what's going on there. Very few people actually said we have all the information we need to understand performance issues. You know, this is kind of a layup question for us and for you, because most of the time that's not the case, is it? And then about 1 out of every 5 of you said our organization is moving away from always on infrastructure. Uh, Many people are doing API testing, about half of you. So I'm going to stop sharing that. Thanks for sharing your part in that. Now, I am going to move quickly because I have a lot to share. What I try to do is make sure that I listen to customers and I deeply engage with them. A lot of you are on the call right now that I've worked with very closely and very dedicated in both ways, on both sides, very dedicated to making sure that you're getting to what you want. And in many cases, if we just talk really briefly about sort of the extreme ends of things, sometimes extreme, sometimes not, depending on who's talking. But there's two extremes, right? If we level set for a second, the goal here, in many cases, the work that we do is to build predictable and resilient systems, right? Things that we can rely on, things that we don't have to constantly firefight in production. And what we see on two ends of this extreme are obviously brittle systems, and that just coincides with this thing on a regular basis, which is very low or maybe no automated processes. I don't just mean automated testing. I mean, how do you get that thing out? Pressing buttons all the time, logging into servers, manually doing all this stuff. That's pretty dangerous. On the opposite extreme are highly resilient systems that have a high degree of automation, not only in their testing, but in their software and their practices and their processes, right? Even go so far as to say maybe the improvement process has a high degree of automation in it as well. And so my goal here is particularly to ask the question, what are some things that I've learned that we as Neotys have learned from customer engagements, as well as what are the customers that I talk to learning in order to bridge that gap, right? In order to make it over the precipice and start making progress or double up on some of their work. And that's what we're going to be talking about today is what's in this gap. So the problem, though, is there's a challenge in front of us. It's a big rock. Um, the old performance model, the way that we would wait at a certain part of the release train to do certain, stabilized work, and then kind of a big blast at the end, it doesn't really fit because I had to draw this on a whiteboard, as you can see, for somebody coming from the business side that didn't really have a lot of technical experience as to why late cycle feedback is so damaging, particularly damaging to velocity, but also particularly damaging to what might be out in production. And so what you end up with is that if testing happens late and it takes a long time, let's say work done in sprint 3 needs feedback that takes a long time to get to, guess what? They're going to move on to sprint 4 and context will be lost. And worse, when you actually get to the point where you do have results that are maybe actionable, you're interrupting maybe sprint 5 work. And so now your velocity tanks, or you commit huge amounts of effort, acts of heroism, so to speak, and then burn yourself out. And guess what? After that release train, everybody goes, phew, and now there's a whole new release train that you have to deal with. And oh, by the way, these things leak not just into production, but leak over into the next planning and PI cycles, right? The goal is that what we want to do is shorten this stuff up, right? So one of the ways to do that, and you'll hear this from a lot of different places, is to be able to automate what you can automate, right? Automate as much as possible. Not everything, because there are some things like fingerprint reading is still kind of difficult to automate on mobile devices. There are some problems that don't come out unless you actually put pressure on it and have eyeballs on it. But for the most part, the goal, the approach here to satisfy the goal is to automate as much as possible in order to drive to fast go, no-go decisions, right? And so we would automate pipelines, right, in order to build the product and maybe even shove it out the door. But guess what? Testing is a really important part here. And I think, Lisa, are you with us today?
I am here, yes.
Hey, I've got my friend Lisa on because a couple of days ago, I was like, what's a good test only visualization of a pipeline? And I looked online and this one popped out. I was like, I like that. I like that a lot. And then I drilled in and it was like testing in DevOps. What's that? What's this? What is it? The state of dev test ops? Can you tell us a little bit about that, Lisa?
Well, testing in DevOps is a community site that I curate, and the goal is to get testers interested in learning about continuous delivery and DevOps and get engaged in it, because we know we need testers. And people see the word DevOps and think testing isn't involved, when in fact it's the core of it.
Oh yeah.
And the goal of the survey that Mabel is sponsoring is to just see how testers are engaging, see how teams are doing testing activities to as they move towards continuous delivery and using DevOps practices. And you know, we especially this year we're looking more at how are testers getting engaged in the release pipelines, deployment pipelines, operability, things like observability, monitoring, logging, testing in production. Are testers getting involved in that? Are teams doing those kind of activities? What techniques are they using?
Mm-hmm.
And how do testers feel about it? Last year, one of the interesting things that we found from the survey was that the testers who said they were on teams doing continuous delivery had the highest levels of stress. And so
Oh
it's like, well, there's something wrong with that picture.
yeah.
And I've talked to a lot of people since then, and a lot of teams say, okay, well, a lot of companies say we're going to do continuous delivery now, and they get their pipeline going and they automate some tests. But there's a lot of other testing to do. Like you say, not everything can be automated, and probably not everything that can be automated is automated.
Mm-hmm. Mm-hmm.
And so they kind of just leave it to the testers. Okay, well, do what you do, but you got to do it really fast now.
Yeah. So this survey that you have out is the second year in a row. And have you already closed input into the next year's survey, or have you released that yet?
No. We're still the survey's still open, so we're still looking
Great.
for input for that. So we
Okay.
really hope that people involved in this will go and tell us what you're doing.
Okay. So the over 500 plus people that we have registered for this webinar who might get this stuff, might not be here today, but will get this stuff, maybe they should go over there and fill out their information so it's more statistically relevant. Good, good.
Yay! Awesome. Thank you so much.
Yeah, and thank you for being on. Maybe later, if you've got some questions, you can pop those in.
Awesome.
Cool. So yeah, so that's an example. Also, another example of automating as much as possible comes from Stephen Townshend, who is one of the contributors of many of what we have is called the Neo pack, right? The Neotys pack, the Performance Advisory Council, and this is not only a retreat in once a year for performance engineer aficionados, but also there's a virtual pack that just actually happened a couple weeks ago. And if you want to learn more, particularly about this topic in there, you can just, by the way, the deck is completely available before and after. I've pasted in the link to this deck, but don't get distracted. I got stuff to say. But the goal here is to be able to do all your testing and do it in a timely manner so that it actually fits the clock cycles, right? So that's what he talks about. So I'd check that out too. The way that I like to describe it, and I think a couple of you have probably seen this slide before, but is that there is a modern mantra about feedback. It has to be early, it has to be often, it has to be easy, right? If it's not all three of these things, it doesn't really fit into a continuous motion or an automated motion in order to build trends out so that we can actually see, is this a net new problem today, or is it something that's just kind of the straw that broke the camel's back? So what I mean by early is typically most customers that I've seen start with APIs. They're simple. We'll get into that in a second. But also this allows people with many skill sets to be able to contribute to the pipeline, whether it's testers or devers or whoever it is, right? Automation engineers. The point is there's a lot of contributors if it's easy and if it's early. If we skip past a couple of things, again, I'm going to go fast and you can refer to these slides later. The easy thing, right, is really important. And this stuff that we do, particularly in performance, some people have an aversion to even the notion that it can possibly be easy. And I'm not interested in selling vaporware, right? I'm not interested in selling a concept that doesn't really apply. What I see, though, is that people who have an easier time with something, right, particularly when it comes to API testing, and even in some cases the end-to-end stuff, are able to fit more in. and therefore able to squeeze time cycles down so that this feedback comes back more frequently and more immediately to the cycles of sprints particularly, and so that the developers can actually synthesize this information back into what they're doing. They don't lose that context like the challenge slide that I had there, the old model was stuck on, right? So one of the things that I promised in this webinar was a couple of stories from enterprise scale performance teams. And they're anecdotal because I like to respect the anonymity of some of the folks that are doing this awesome work. But you might also recognize some of your own work for folks who are on the webinar. So the first one I want to talk about is that API low complexity thing, right? They're the first priorities. That's the first target for testing. So if you see on the left, there's an example of our new approach to being able to describe these tests. The first one is obviously an API test, and it's pretty low complexity, but it does include something like OAuth, right, the OAuth process. So sometimes what you'll get is a client secret in a static resource or in a pre-login step, and then you might actually have to use that in order to ask for the next one, which produces what's called an OAuth bearer token, right? So this is the type of stuff that you should be able to describe in a very simple way, because the surface area of the API is easier, right? It's easier to define and design your tests. It's easier semantics. We talk about syntax, right? We're talking about standard HTTP calls. The payloads are oftentimes simpler, even though you might be posting a lot of REST to a REST service, a lot of JSON, or things like SOAP, big bodies. For the most part, the payloads in APIs are much easier than to have to do a complex post or a multi-part MIME post in an end-to-end application. Also, test data sets are oftentimes simpler. By simpler, I simply just mean the inputs to an API, even more complicated APIs, are smaller and more discrete, right? And this is what we're getting to. We're starting to cut off all the stuff that gets out of scope of actually verifying that API performs correctly and also performs at scale. And finally, with APIs, you're not having to deal with all the static content types or potential third parties necessarily. By default, usually end-to-end tests have that. So the outcomes and reports are, quite frankly, simpler for people to synthesize. It's not just easier, it's faster, right? Machine-to-machine readable formats such as OpenAPI, you might also know that as Swagger or SOAP, right? Even the old SOAP WSDLs, that those downstream activities in a testing tool get easier if you're handed a description of the API. Also, the APIs are earlier to prototype. I've seen a lot of people use virtualization tools in the enterprise, but also like you could just rip one of these things yourself and just put it in a container and ship it to your test environment or ship it to your testers. Gosh forbid, testers actually run Docker containers these days, which happens. So the prototyping is actually earlier and therefore it's faster as well. And then finally, when it comes to what we're trying to accomplish, I also like to consider that particularly load testing is not just about experiencing it like the end user, right? Load testing is just a technique that is a tool in our tool belt to do what? And in many cases, I find that it's far more useful to use load testing as a fault isolation technique, one of many. You might also rely on logs or on APM metrics as an impact metric to actually understand more about your system. But being able to have targeted fault isolation is very important, right? So people are able to pick their injection points, which particular APIs they want to put pressure on, rather than relying on an end-to-end scenario that puts pressure on everything, right? We can be more targeted and precise about that. The second customer story here is, quite frankly, dynamic provisioning, dynamic infrastructure, right? Rather than renting a bunch of servers and hooking them up to CI, or utilizing load generators that just sit around and do mostly nothing most of the day. That's the old way. The new way is to use dynamic infrastructure, on-off type stuff. That was the question in the poll that I was asking. It takes planning, though. It takes planning. It takes skills building. On the left, there's an example from one of my really treasured customers that is talking about how they actually dynamically define the container for use in Jenkins, right? And so this kind of stuff, if this is unfamiliar to you, it's not surprising. It's okay, right? It was unfamiliar to me a couple years ago too, right? It's net new technology to our domain, yet that doesn't mean we can ignore it. In fact, that requires us to actually not ignore it, because this stuff's happening in production. You know, if people are using, let's say, containers to release to production, and you're a performance engineer, and you know nothing about how that technology works, how are you going to be in that conversation, right? Better yet, the release process that's over on the right here is an example of one of our other large customers that are actually, instead of using containers, they're using AWS, right? They're still using classic AMIs, virtual machines, and they're launching our controllers and load generators at large scale in that manner. And they're actually automatically describing those things. They're using templates, but they're also describing those as a process, right? And this is just a declarative pipeline in Jenkins. And then they're going and running NeoLoad, and we'll see an example of that later on as well, right? But it takes planning. This stuff takes a little time to get used to. This is my favorite one of this notion that we do all this work up front, right? We get our criteria. Let's imagine that that's perfect, which it never is. We create the tests. Then we do some work to get these initial performance results provided. And guess what? It's not perfect. Things are broken. There are particular stress points in our applications and our API chains. And so hopefully fixes occur, maybe, right? Maybe it's some code that's poorly performing, or maybe it's actually a configuration point in the way that people have deployed. And it doesn't matter what environment it is. If it runs really poorly in a low environment, it might also be likely to run very poorly in a environment that's got lots of muscles and lots of redundancy. So maybe fixes occur, then they ask to retest. Well, yeah, of course, you want to really make sure that your fixes worked, and then you run your tests. But the question is, how many more times, right? How many more times do we do this? I wish I put this as a question to the audience in retrospect. How many times do you have to retest on average when there is net new functionality? And so the goal here is to make sure that the people, if you've already done the work up front, let the people who need the retest just retest, right? You don't want to get in between them and the closing of their cycle. It's a dangerous place to be. As testers, as service providers, that's a pretty dangerous place to be. And unless you're in charge of pressing the button, right? Unless you're actually putting yourself in that danger zone, let them press it, right? Let them rerun their test. And that takes a little automation too, right? This is what I work with customers on all the time, is to make this a repeatable process that they can hand off, and then they can scale the actual performance engineering to problems that actually require that subject matter expertise. A retest doesn't necessarily, but the caveat here is that the more complicated the testing is, right, the more elaborate the analysis is, right? So you do sometimes need those subject matter expertise to come back in and say, oh, so you retested and maybe you need some help interpreting the results. That's still something. Like, we're still human beings, right? We're the original intelligence. So it's fair to put it that way, but to make this a dumb button that people can press when they need to, we're seeing a lot of customers actually go that route, at least with API testing, if not automating that on a regular basis, right? There's an example here from another customer. Going back to that notion of how many times you get a retest, I'm going to read this out. This is a direct quote from one of the chief architects at a Fortune 40. Okay, and this was during an architectural review board session. He says, "I want to give you a common scenario: scripting, script testing, executing load tests, finding memory leaks or low capacity, re-executing the test with no changes to the script. I've had to re-execute up to 5 to 10 times, making changes to the app to get it to scale to what fixes. Every time someone pushes the button, we have to pay again? Am I going to be paying the upfront cost and then the multiplied cost of every time a retest occurs, up to 10 times, just to meet my goals I'm trying to achieve? This is our most common use case. How are you going to quote us that?" So that was a direct quote. I think it was 3 weeks ago, actually it was a little 4 weeks ago, from a pretty serious. I would be grateful and honored to work with this individual. He really knew his stuff, and he knew the business part of his stuff as well. So just think about that, right? How many times do you really think you're going to need to retest? The third of four stories here is performance trends. I'm sorry, the fourth of four is performance trends, right? If you want trends in your performance, you're going to need to build up some conventions, right? It's not a nice to have conventions. It becomes a requisite. The first one is meaningful definitions of your SLA. And by SLAs, I'm using the specific term from most load testing tools, not the Google's version of SLA, SLO, SLI. It's just the SLA is within what range do we expect this thing to be before it either passes or fails, right? And those definitions really need to be something you can pull up in front of anybody on your team who's involved in building something out and say, is this even close to what you expect? Or let's define it up front and then let's run a couple tests and we'll see how it actually plays out in reality. And oh, by the way, these are different per environment. Your QA environment might have slightly different SLAs, but it's still important to know that those red flags are being hit early in advance. And also your production, of course. And I was talking with somebody online on LinkedIn earlier last week from one of our larger customers, and they're really forward thinking about how to do continuous integration and performance in pipelines. And he basically said, you know, the way that I get my SLAs first inked, when I don't know anything, is I take a look at some of the production environment and I see what other services are like this that have an anticipated load. But at some point, it's a guess, and then we have to feed production information back into the testing model. This is sort of like the shift right, the ops feeding back into this information. Also, there's a couple of things that people do on a regular basis. This screenshot below is the most common comparison, and people use our API data to get to this stuff. There's also a couple of things in our graphical tool that designer and results to do something like this, but for the most part, they're looking at percentiles. They're looking at a deviation of percentile between a couple of runs, right, and across specific and really important transactions to them. So when it comes to things like mean reversion per transaction, that's important. Also percentiles out of bounds, right? That's something that I actually worked with a customer of ours to build out a quick process early last year to do that. And here's that example, right? This is an example of the transactions, but also comparing their percentiles, right, between each other. And if you want to actually play around with this, you're more than welcome to. I put the generic version on GitHub, and you can, again, all this stuff is in the deck. So some of the key learnings that I have been able to collect gratefully from my experience through Neotys with a lot of our Fortune 100 and plus customers is distills down into four things, right? We need to stop waterfalling this go, no go process. And I'll tell you what that is in a second, that there are multiple ways to actually inject load testing and performance in CI processes, but still the goal is to be able to do a go, no go, right? That actually the cost of static versus dynamic provisioning is surprising, and I've got a slide for that. And a few key enablers that I want to go over for folks in the room who are like, I think I want to do this. Well, okay, and let's be honest, it's not something you take lightly, but it's something that we can help you plan for, right? And you can get it done. If there are some customers I've been surprised that they've made the strides they have, and I'm glad for that. So if they can do it, you can do it, right? There's all sorts of folks that are trying to do this, and we're trying to make sure that that information goes out to everybody. So the first one is the classic pipeline for continuous performance testing looked a little like this, right? You got some static infrastructure, you attach it, maybe you make it a build agent, and in your agent, that's where the work does to pull down, let's say, a project, prepare the test, run it, and then make a go, no go decision afterwards. And if it's a green, maybe continue on with something else. If it's a red, maybe get a person involved. Right? That's the old model. And I've seen countless examples. I know there's folks on the call who have this right now who are going, hey, that looks like mine. Well, because that's the truth. This is what it is. In some cases, you do your test, and the go no go is essentially a jar file, right? That has some kind of custom process that you do to take the results, compare them, and make a go no go decision. And you know what? That's pretty awesome. It's pretty awesome that you've gotten to the point where you can do that. There's a slightly other take on this, which is that if we want to actually fail fast, we need to decouple the go no go decision from the waterfall approach to wait for the test to be done completely. And with a number of our APIs, you'd use a combination of APIs attached to NeoLoad Web, as well as interacting with the direct controller if you needed to actually cancel or stop the controller. But the idea is you go through similar processes, right? You might even actually use a provisioning platform like some kind of EKS or Google Kubernetes engine or something like that, if you're lucky to have a cloud. If you're not, it might be on-prem. It might be like Pivotal Container Services or something. Or maybe it's just a Jenkins sort of Docker host off to the side. That's fine too, so long as it's reliable. But you spin up your containers. Maybe one net new thing is you spin them up as Docker containers. And then you can actually start making faster go no go decisions rather than waiting for an hour for that sort of burn-in test to verify memory leaks. You can actually quit out of that process much faster, right? But think about it, that takes input, that takes context. And if you're going to automate this, it has to be something that an automated process can ingest as the context that otherwise you would be sitting there with your human eyeballs waiting to press the stop button. So in this sense, what we need as input to the go no go fast fail is what are the key service level indicators that you care about? And particularly, SLI stands for service level indicators. That is your classic measurement over CPU, net RAM, disk, load, health and strategy, maybe some monitoring metrics from your APM tool. That's just a point in time piece of data. It means nothing. The context around that data, which is called a objective, a service level objective, or an SLO, gives you that range, right? And so in, let's say, NeoLoad, what we call SLAs are really more close to the SLO concept, right? Within this range, if it goes outside that range, let me know. And your go, no go decision might actually be your own logic. It's still fine to customize this process, but you have the APIs to get this information and do this in an async manner. And that way, rather than waiting for an hour, right, to fail out, it might be a couple minutes within. But the whole point is, without this context, there's no way to really do an effective sort of fail fast in an automated go no go decision. And guess who's involved, right? Guess who's involved when this doesn't work? Well, it goes back to the team. And you're familiar with, you're probably all familiar with working with product teams and providing them the performance data, but maybe not actually making sure that they synthesize it. And cracking the whip doesn't really work. So the question is, if we're able to actually synthesize those learnings back into the SLOs, or the service level objectives, the definitions of our API, of our SLAs. Now, if it's written and if it's part of an automated process, guess what? People have to kind of do the right thing, right? They have to talk about it earlier. So that's the notion of the async versus classic mode of the pipelines, and how faster go no go really has to be an async process. There's also a quick touch point here, now that we're rounding up on 20 minutes, that I want to make sure everybody understands some basic stuff about automated process, automated CI processes, and particularly in load testing, right? So there's a classic model, which means that your build agent on a CI system also has a load controller like NeoLoad installed in it. Now it runs headlessly, but in many cases, a lot of people just choose to install that on a always on VM, like in Windows, and then attach the Windows agent to their CI process as the build agent, so they can actually do work and kick off the NeoLoad process. The problem with that is that, if you think about it, if you're wildly successful, guess what? That's not just a good problem. That's actually kind of a bad problem, because how many of these always on things are you going to do? Are you going to ask for? I mean, how many approval processes do you think you need to go through to support another 5 or 10 teams? Oh boy. And then this stuff is always on. And the CFO is going to come around to you going, why is this stuff running all the time? Maybe you're the last department, I don't know, to still have like just dedicated infrastructure for no good reason that doesn't actually prove its value more than like 15 or 20% of the time. So this notion of like we need to supply load infrastructure that is appropriate to demand. The problem is if you've got all these like always on things and you've got maybe 10 controllers and you've got 20 different teams that could kick this process off at any point in time. Remember, that was the approach of fast go, no go, and autonomy, that you're going to run out of resources here. So the next step is to maybe say, well, let's better match the supply and demand, the supply of the load infrastructure with the demand of the CI jobs wanting to use them. And so that dynamic model means that you probably would build an agent as a controller, right? The build agent is the controller still, no difference there. But these are dynamic containers. And a lot of our customers are actually starting to do this model. And that's a great next step. Again, this is a sort of a journey. And that helps you to match the supply with the demand. We've got a couple of slides for that just to visualize this, so don't worry. But the problem is you need to know what your container provisioning model is, especially if you do this on-premise or with a classic CI tool like Jenkins or Bamboo or TeamCity. And then there's a third one, which is, wait a second, maybe the build agent doesn't need to be the controller. It could just be an instigator of that process. It just calls out to, let's say, your NeoLoad web instance or your SaaS, the SaaS version of that. But what does it say? It says, please start me a test. But we still need to have resources to run the test, right? Yeah, well, you can attach your static or dynamic resources to what I call a mesh, right? A hub, which would be NeoLoad web resource and runtime. And the only thing about that is that you'd probably need to match the supply of your dynamic infrastructure with that demand. And it could just be as easy as basically saying, hey, attach some containers to NeoLoad web before you instigate a test and then tear them down, right? So I've got an example of Azure doing that as well. So the legacy model is to build this all into the agent host and then to hit your system under test with the controller or load generator. And maybe it takes an extra plugin from the CI system to do that. And then you still have to put your test results somewhere. Maybe if you want the raw stuff, you have to, volume map into the agent host and copy those files out. It's kind of a mess, right? It's the classic, the legacy model. And it's pretty heavy even when it comes to CI process. The one that I described the next step was to use a more container or dynamic infrastructure model and ask for a dynamic agent host that is built from, let's say, a Docker file or something like that, or already baked into one of your artifact repositories. So just go reach out for that from your container provisioning platform. And it's about the same model. You're still executing this, but you're doing it in a more declarative way. And that's some of the examples. I've got a slide for all of the stuff that links to examples of these kinds of things. So don't worry if you're missing a couple points here. But still the con is that your provisioning stage really detracts from the purpose of the pipeline, right? If you're doing all this provisioning work, it gets kind of cluttery unless, let's say, your pipeline approach has first-class citizen support for containers. So the final thing, that mesh model, is to match supply and demand by essentially decoupling them. As it turns out, decoupling this thing simplifies things, right? If you can maybe spin up your resources, let's say, this is using 2 clouds because I'm working with a customer who's doing this, but it could all be in the same cloud, but your load infrastructure maybe is separate and yet attached to NeoLoad web. And then the demand for that, which is the number of jobs that need those resources, just need to tell what I'll describe in a second, the web test launcher, need to just call out and say, hey, I need to run a test and I want to use stuff from this zone. And so long as you put stuff in the zones that the jobs are for, so long as you match that supply with the demand, then you're good. You're good to go. So the other point I made earlier was that the cost of this is surprising. In most cases, dynamic or on and off type infrastructure is significantly less than just letting things run a lot. This is an example of somebody who ran some numbers, and what they found was, percent utilized for both controllers and load generators was around 17% of the time, and it costed them about 120K to do this. I mean, this was a very large built-out model. Okay, they looked at some of our cloud resources, using NeoLoad, the load generators in our SaaS cloud, and they recalculated as this, right? So that they really only have to spend essentially half to do this. But again, whether you use our cloud or whether you want to spin this on your own, maybe you've got some serious compliance and security considerations that you want to spin this on your own in your own cloud. Guess what? We're already there. We're getting there, right? Like, we already support OpenShift for folks who have OpenShift on premise, and we're really going to double down on the ability to support pretty much anything that can run Kubernetes in 2020. So you'll be able to spin your own stuff in your own cloud if you want to, or in your own on-prem sort of dynamic provisioning space. So the cost of doing business here would port over to that model as well. I thought that was surprising. So the last few things, and this is high level, and you're always welcome to reach out to me on multiple social channels, or a lot of you have my email address, so don't be shy. Don't be shy. These are some of the things that I feel are coming from customers as the key enablers to actually being able to do automated performance in go no goes, right? At the top level, let's just start with what we need as input to the requirements process. We need a clear understanding of our service level objectives. That doesn't have to be the be-all, end-all SLA that never changes. In fact, it has to change over time, but we need to start somewhere. We also need to know what to look at, what particular pieces of information to look at. And in fact, you probably already know what those are. You're monitoring those on a regular basis. So it should be relatively easy, if you haven't done this already, like some of our customers have, is to provide ranges or objectives around those indicators. And more importantly, I think it is important, once you get to scale, to understand what your requirements intake process is. In fact, I was working with a customer earlier this week that they're building out forms to basically make it absurdly simple for developers to just paste in some basic details about their new API endpoints into a form that gets ingested, and it produces our YAML-based flavor format of load tests, so that it can run at a small sanity check just to make sure that this thing worked, and also, by the way, run it for an hour at large scale, by default, just by a developer walking up. It's not just a button that you crafted for them; it's a process that they can use to create their own button, so to speak, right? Underneath this, though, is the notion that you have to have a good approach to test design. A lot of folks that are on the call that are customers already understand what I mean about that when it comes to NeoLoad, the desktop designer. You also have to have a really solid execution engine, and one that is not capped in terms of what it can do, and disabled in terms of being able to be in multiple geos or spun on your own infrastructure, right? Think licensing costs from the old dinosaurs, right? That's a problem. So you need to have an execution engine that is something that people can trust, and something that people can be that can be flexible to a lot of different use cases. You need a place you store your results, and for us, that's NeoLoad Web. You can stream your test results to there and share those out with your teams. And also, we're building out this notion of trending, being able to take seriously this notion that trending over time is a critical core component of doing this in an automated, continuous manner. And so that like what Joe was saying earlier, so that when it comes to context, that if this is just a problem that occurred because today was the moment where the straw broke the camel's back, and it's not a problem on a regular basis, except for all of a sudden it is. If you want to differentiate those two situations, you need trends, historical context. And then the final thing underneath all this stuff is you need to start looking at pipeline orchestration. If you haven't, pipeline orchestration, like the pipeline code. I've got a few examples I'll show in just a minute. You also need to reach out and talk about what is your dynamic infrastructure or your container and virtual machine provisioning strategy? If you're already, knee deep in that, fantastic. If you've never thought about this before, now's the time. Even if you're not trying to automate all the things, you should know about container orchestration, right? You should know who in your teams are involved in that and start having conversations with them about what are the challenges there, right? Seed the conversation early. The last thing I think, though, it actually turns out to be sometimes the first thing in test design, is use the same, if at all possible, use the same repository, like source code repository model that your devs teams do. Like in most cases, a lot of enterprises are moving to Git, and not necessarily a flavor of Git like on-prem or hosted or enterprise or whatever, but the underlying technology of Git is what most dev teams tend to use. And then why wouldn't you do that with your tests? So you can version, branch. A lot of folks at scale are already doing this that I talked to. So the net new thing that actually we just updated a couple days ago, but we released very recently, is called the NeoLoad Web Test Launcher. And this is that thing that I'll show you where it sits. We've had Dockerized version of controller and load generators for more than a year now, if I'm doing the math right. And the Web Test Launcher is that lightweight thing that just instigates a process through NeoLoad Web. And you can get all this information right on our Docker repository. There is alternatives to using the pipeline that your organization forces you to use. This is something that we're actually working on. One of my coworkers and colleagues, Henrik Rexed, he's actually worked very closely with Andy Grabner from Dynatrace and a whole bunch of other people. I believe the process is moving towards, if not already there, by contributing this to the Cloud Native Computing Foundation, the CNCF. And the idea is to be able to do go, no go, build over build reports in a way that's very pluggable and autonomous, by the way. Right? If you don't want to use the same build system as your dev team, but you want this to kick off, this might be an option for you. So I promised you a bunch of resources, right, for later deep dive. I've got a ton of blogs about this. Also, this deck you can get at with not only after the webinar will be emailed out to you, but at any point in time you can click through this. And the examples here, I want to go through one or two real quick, and then we'll open it up to questions. We have examples for Jenkins, GitLab, AWS Code Build, Azure DevOps, TeamCity. I have not included Bamboo, but Bamboo is in there as well. And basically anything that can execute either a Docker container and or just a Linux command shell or a Jenkins, a Java process, there's a way to plug it in. It might not be like laid out for you, but we can work with you on that. So let me hop over real quick and just show you what I've been building for some folks. I mentioned earlier the pipeline process needs to treat containers like a first-class citizen. And here's an example of an Azure DevOps pipeline. I built this in approximately 24 hours, right? From knowing nothing about Azure DevOps, but understanding the concepts that we've been talking about here. I built this out pretty quickly. I've abstracted some of the secrets here, but for the most part, this is what I mean by first-class citizen. Containers being a first-class citizen to a pipeline. Instead of having to tell it where to get the containers, or remember that slide where somebody was spinning up AMIs and having to run the AWS CLI inside the container just to get that stuff to work? Hey, that works, but maybe if your pipeline is already hooked up to a container orchestration platform, all you have to say is, I need some resources. There are containers I need. Here's the controller. Here's the load generator, right? And oh, by the way, when we actually get into the steps of doing this stuff, right, like executing a NeoLoad headless controller, please use the container controller, right? So again, just to let you know, that's this example right here, Azure DevOps, and it goes right to my Git repo, and you can take a look at it yourself. And keep in mind, we also have that classical model from Jenkins where, like, if a build fails, hey, look at that. Why does it fail? What's the NeoLoad process look like? Uh-oh, it's failing because, where is it? Exit with status code 1, the SLAs. the SLAs were problematic. And so if I look at that report, I could just open this up. It could even, I think I could even go to Slack and I would see that there is a latest build that failed. I click into build 24. There are a couple errors on the end, but why did it fail, right? Let's take a look at SLAs. Oh, geez. Oh, yeah, that's right. There was a RESTful API call. We had an SLA on, and we were actually starting to tap into some of the other ones as well. So this is how easy it should be for people who see something didn't go right to be able to jump in to figure out exactly what did not go right. So these examples as well are pipeline. It should be as easy as basically just saying run NeoLoad, right? I'm using some Jenkins shared libraries to simplify some of this stuff. And to be able to actually execute different contexts. If I want to do a quick sanity check as one step of the pipeline, just make sure my infrastructure is still working, right? Versus the actual full test, I should be able to do that and write these things dynamically. So with that, I think we should probably switch over to Q&A real quick. We've covered why we do this, some stories from the enterprise, my key considerations coming from customers for automating go-no-go decisions, and then examples from the NeoLoad pipeline.